Okay, so in class today we started talking about how to graph absolute value equations, and we've graphed absolute value equations using a table. But we briefly talked about different transformations that we saw as we were graphing these absolute value equations with tables. For example, what happened when I added 3 on the outside of the absolute value bars, or what happened when I subtracted 5. We saw a vertical shift, okay, or what happened when I multiplied the absolute value by a negative. We saw that it flipped. Or what happened when I multiplied the absolute value bars by a 4 or 5, we saw that it became steeper. Okay, so all of these transformations and all the things that we discussed today tie in with the absolute value, with the vertex form of an absolute value equation, which will make it a lot easier to graph absolute value equations. So let's get started. This is the vertex form of an absolute value equation. It may look complicated, but make sure you write it down, and we'll talk about it. We'll work this out, and you'll see why all of these components are important and what each component means, okay? But the main component is your actual vertex. So if an absolute value equation is in vertex form, it is incredibly easy to figure out the vertex. The vertex would be h and k. H comma k. HK is the vertex. Now keep in mind that, or not keep in mind, but I want you to notice that the absolute value, the vertex form of an absolute value equation calls for a negative h, right? So, and if you notice here, we have a positive h. So basically what that means is that the h value is going to be opposite. So if this was x minus 5 plus 3, your vertex wouldn't be negative 5, 3, it would be 5, comma 3. Or if this was x plus 2 minus 4, your vertex wouldn't be 2, negative 4, it would be negative 2, negative 4. And there's a way to remember that, and there's a little dance that I'm going to show you tomorrow that helps you remember that the inside of the absolute value bar, that portion of the vertex would be opposite, whereas the outside of the absolute value bar wouldn't. And I'll show you that tomorrow. But for now, just make sure you write this down, and make sure you especially put this down in your notes and put some stars next to it, because this is the vertex form of an absolute value equation. I'm sorry, before I leave this slide, I want to talk to you about a few other things. I also want to talk to you about A. A is going to represent our slope, and positive A is going to be the slope on the right side of the vertex, whereas negative A is going to be the slope on the left side. And I'll show you what I mean by that in a moment. All right, so here we have f of x equals x minus 2 and then minus 4. So as we spoke about today in class, this minus 4, we know, we spoke about this in class when we were graphing these using tables, we know that this minus 4 is going to shift our entire absolute value graph down 4 units, right? We know that. Now, what is this minus 2 going to do? This minus 2 is actually going to shift the absolute value graph to the right 2 spaces as well. And you'll see that in a moment when we graph it. So this absolute value graph is going to be shifted down 4 units and to the right 2 units. Okay. Now let's go ahead and graph this using our vertex form. Vertex form is, let me write it down again, and you might want to write it down as well so you remember. F of x equals a times the absolute value of x minus h plus k, where h comma k is your vertex. So if we look at this problem here, what would our vertex be? Well, the number inside the absolute value bar is negative 2, but remember h is going to be opposite, so it won't be negative 2, it would actually be positive 2. And then k is negative 4, and that would just make our y value of our vertex negative 4. So the vertex is going to be 2, negative 4. So what we're going to do is we're going to plot that on this coordinate plane. 2, negative 4 is right here, and that's my vertex, that's my turning point. That's where my V forms. Now A, what number is in the A position? Because that's going to tell us our slope. Well, it might not seem like there's a number, but there is. There is a number there, and that number is 1. There's a 1 there, so A is going to be equal to 1. which means our slope is 1. That means we're going to rise 1 and go to the right 1 as we go to the right of the vertex. But if you remember from the previous slide, when we're going to the left of the vertex, we need negative a, which negative a is going to be negative 1. So our slope is going to be negative 1 when we go to the left of the vertex. So starting at our vertex, we're going to use our slope 1, 1. So we rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. But when I'm going to the left of the vertex, I'm going to use the opposite slope, which is negative 1. So I can't go down 1 into the right 1 because that would take me to the right of the vertex, and I just want to stay to the left. So instead of going down 1 into the right 1, I'm going to go up 1 into the left 1, up 1 into the left 1, up 1 into the left 1, up 1 into the left 1. And that right there is your absolute value graph, and you didn't need to create a table. Okay. Now, what would the domain be? The domain would be all reals, and by now you should be able to figure out your domain and range. Your range is going to be y is greater than or equal to negative 4. But we did this without a graph. Let's just do one more example. All right, let's do this one right here. Here we have negative 3/4 times x plus 7. You might be saying, Mr. Ramos, there is no number in the h position. Yeah, so what represents nothing? 0, right? So your vertex is going to be 0, 7, okay? And let me write vertex form up here again. Remember, vertex form of an absolute value equation is f of x equals your a, which stands for slope, times x minus h plus k. So in this case, the vertex is going to be 0, 7. What's your a? Your a is going to be negative 3/4. And we're going to use this when we're going to the right of the vertex. However, when we're going to the left of the vertex, we need to use negative a, which would be positive 3/4. Or when we're going to the left of the vertex. So let's go ahead and plot our vertex. Our vertex is 0, 7, which is up here. And I want you to notice something else. This is a negative. So what do you think that's going to do to our absolute value graph? It's going to flip it, and we also talked about that today. So you should recognize that negative is going to flip the v, so the v is going to be facing downward. All right. Now, as we're going to the right of my vertex, I need to use this slope, which is negative 3/4. That means I go down 3 and to the right 4. And let me change this to blue. Down 3 and to the right 4. Now, as I go to the left of my vertex, I instead need to use this slope, which is positive 3/4. Now, I can't go up 3 and to the right 4 because that would take me to the right of my vertex, and I want to stay to the left. So instead, I'm going to go down 3 and to the left 4. Now, if that slope thing confuses you, another way of thinking of this is that these 2 points here need to be a mirror image of each other. So if there was an imaginary line here on the vertex, those 2 points would be a mirror image of each other, meaning they'd be the same distance away from each other. If that's easier for you than doing the opposite slope, okay? Whatever's easier for you. All right, and then if we go down 3 into the left 4 again, we'd be right over here. Again, a mirror image of that other point. And that's your V. What would your domain be? Your domain would be all real numbers. And what would your range be? Your range would be y is less than or equal to, and it's less than this time because our v is pointing downward, 7. Okay, now we're also going to talk about this 3/4. Some of you might have mentioned that, might have noticed that this graph seems a little, I guess you could say, wider. And we're going to talk about why it's wider tomorrow. And we'll do some more examples using vertex form. But make sure you have this written down in your notes, especially those steps on how to graph using vertex form. And that's it. I will see you tomorrow. Have an awesome day.